Next, our program is about string. String is nothing but group or set of characters. And our next program is to move the from one string from one memory location to the another memory location. String is nothing but the group of characters. Okay. So that group of character where whichever stored in the memory, we have to move from one memory location to the another memory location. It can be done with the help of string instruction movesb. It can be done without instruction movesb. Now we'll see that the program is divided into two parts. One program that I had done with a movesb instruction, and one is done without movesb instruction. So this is our 10th program. I have stored with experiment 10a part. Edit experiment 10a dot asm. It will open the program. So this is the title of our program is to move the string stored in the memory from one memory location to the another memory location. So this is our title of the program, and it is written with the help of assembler directive title. As usual, I have declared dot model small dot data. I have written. Now what is my data? Data is nothing but my string. Okay, so here I have taken source one variable, or we can say string name is source src, which is of size 7 bytes. Here I have taken string by space by. So by will contain 6 characters and space will be treated as 7 characters. So each one character is stored at one memory location and it is defined by 1 byte. So our source string variable is declared with the help of assembler directive define byte. Now we have to we have to make the we have to count the how many letters we are moving. So here total we are moving 7 letters. This BYE 3 plus space 4 plus BYE 3. 4 plus 3 7. So total 7 letters we are moving, and that is nothing but the count of the string. So for that we have taken we have declared another variable, that is count. Okay, and it is declared with the help of assembler directive define byte, which is of size 7. So 7 characters are there in the string. Now we want to move the string to the another memory location. So for that purpose, I have taken destination string. For that, I have declared one variable dst, and each will store the byte size data. And there are 7 memory locations, and each memory location is filled with duplicate operator value 0. So at destination, we have 7 memory location. In that 7 memory location, at each memory location, we have value 0. So this is how we have initialized the data. So we have source string having 7 characters that has to be moved to the destination string with 7 characters. Initially it is filled with 0. So this by space by will be stored should be stored in destination string. So this is the motto of our program. Now as usual I have declared the code segment with dot code assembler directive move x comma add data move ds comma x, and for string operations we consider move es comma ax. But for this version of TASM 1.4, the ds and es will work combiningly. The data segment and extra segment will work combiningly. Now what I have done, we know that we should store the count in cl register, so that's why I have used instruction move cl comma count. So count will be it is 7 now, and that will be loaded in our cl register. Now I have taken effective address of source string into SI register. We know that source index register will store the effective address of source string. So instead of this, we can also use the instruction say move I, comma, offset of SRC. So this will also work. So this will also work. Move SI, comma, offset of SRC. So offset address or address of source string will be copied into the SI register. Both will work. Now same way we have taken offset address of destination string into the DI register. DI register deals with the destination. Okay, we know that about whenever we are using string instructions, that time we have source and destination. Source string will be always in data segment with SI source index register as an offset address, and destination string will be in extra segment with destination index register contents are offset address. So here we are taken loaded SI source index effective address of source string into SI register and effective address of destination string into the DI register. Now we have cleared the direction flag. The direction flag, whenever it is cleared, it will execute the program or instruction from lower address to the higher address. So to go from lower address to the higher address, I have done, I have resetted the direction flag. That is, I have cleared direction flag. Clearing the direction flag is nothing but making direct making direction flag as a 0. So whenever direction flag is 0, execution starts from lower address to higher address. So this is a use of clearing the direction flag. Now I have written repeat move SB, move the string byte by byte. So this B is 1 byte, Y is 1 byte, and E is 1 byte. Like that, byte by byte, string will be copied from source to the destination. String will be copied from source to the destination. And this will be done by this byte by byte operation will be done with the help of repeat prefix. This repeat prefix will check the count in CL register. Whenever the compiler move the first byte from source to the destination, it will decrement the CL register counter, which is 7 now by 1. So it will be 6. So 6 characters are remaining to move it from source to the destination. So by this way, the repeat prefix will work. Whenever CL becomes 0, or we can say CX becomes 0, whenever CL becomes 0, that is all characters or group of characters, or we can say string is transferred from source to the destination. That time CL becomes 0 and 0 flag is set. Whenever 0 flag is set, the repeat MOVSB instruction will not execute. It will be halted, or it will stop the moving of byte by byte data, and it will execute next instruction, that is move AH, 4CH INT 21H end. So this is the program which is with the help of move SB, that is with the string instruction. So go to first save it, exit. Now type TASM file name is xpt10a.asm. So there is no error, there is no warning. T-link expt 10a.obj. Object files are linked. Next is td, file name is axpt10a.exe. So executable file, we are executing the executable file. It is executed here. One more thing I have clear about previous here is that in this version, the source and the destination, that is data segment and extra segment will work combiningly here. Now we will execute the instruction one by one with the help of our command F8 for step by step execution. See here, count is loaded as a 7. And immediately the string is transferred from one memory location to the another memory location. And within one instruction, this repeat move SB. Within one instruction, all moving operation is done. So if you want to see the results, see here. See the cursor. So we have source by space by. Okay. And we have 7 characters. And in at destination, we have by space by. If you want to see the repetition again, we will execute this program again with the help of F8. We load it. If you observe carefully, first after execution of this, after starting of the code segment, the first source string is available here by space by. Now we want at destination. So F8 will go on doing F8 step by step execution. See here, we got some problem is there. We will do again. Wait it. Save it. Exit. Turn on filename.asm. Tlink filename.obj. td file. So we'll execute it now. Action exit. So here we have first our source string, and I now, if you observe carefully here, we came up to clear direction flag instruction. Now whenever I execute repeat move SB instruction, immediately all the bytes available in source string will be copied at the destination string. See here at right bottom, sorry, center bottom, you can observe here we have copied the string from one memory location to the another memory location within one stroke, and we have reached up to the end of the string as the CL contents is 0. Okay, so this is how we have to move the string from one memory location to the another memory location with the help of move SB instruction, this string instruction. Now another part of this program is that we will not use move S instruction. We will do, or we will treat string as a group of characters, and we will move one character by character from one memory location to the another memory location. That is the another part of this. Sorry. another part of this program. I've said with the help of experiment 10b.as. So this is the program. We are not using string instruction. So instead of string instruction, whatever operations we have performed, that is the repeated REP move SP out of. Instead of that, we will use the moving of characters from one memory location to the another memory location. So title of the program is to move the string stored in the memory from one memory location to the another memory location. Here, as usual, we have declared the dot model small. In dot data, we have source string welcome. Now we have changed the string. The string is group of characters, that is 7 characters we are having. The string is welcome. Now we are counting the characters. So we have taken that count of characters, so which are the 7 characters are there in the string, that will be declared with the help of variable count, in which we have stored the value 0007. And now at the destination we have created 7 memory locations, which is filled with temporary value 0 with the DUP operator. DUP operator will create the duplicate memory location. How many memory locations it will do? It will do 7 memory location, and that 7 memory location are filled with 0. Now as usual, we have dot code ax dot add data dot d move ds comma x move es comma x. Now what is going to happen here? Here what we are doing, we are moving the string from one memory location to the another memory location after 20 memory locations of the source. Means if suppose we have source at memory location 1 and up to 7 we have stored this in first memory location we have W, second memory location E, third memory location L. At likewise at 7th memory location we have E. So after 20 location means first memory location is W is situated at memory location 1. So after 20th location means 21st memory at 21st memory location. From 21st memory location we are storing the destination string. For that purpose I have moved the effective address of 0020 into DI register. That is destination. My destination string will be stored at 20th location from source string. Okay. Now we have moved the count into the CX register, as we know that count has to be loaded into the CL register and it will be used. Now I have taken effective address of source, that is compiler will come over here and its effective address will be copied into the source index register. For source string, we have source index register. For destination string, we have destination index register. Now I have written that move AL comma content at effective address of SI. Now effective address of SI is nothing but effective address of source. So here effective address of source is here. The compiler will take character W and it will be posted in variable. It will be pasted or moved to the variable AL. So AL got the value of W. So in AL currently the value is W. W means character will not be saved. Some value, ASCII value of W will be stored in the AL register. Now here that register we have copied from AL, which will be, we are moving to the destination. For destination we have destination index register. So at the effective address of destination index register, we are moving the value which is present at AL register. So at AL we have W, that W will be copied at the destination string of the destination string. So a destination string is just 20 memory locations away from the source string. At 21st memory location, W will be stored. Now we have copied one letter from source to the destination. As we have copied one letter from source to the destination, and we want to remaining things. Now what is going to happen here? We have to go to the next memory location. To go to the next memory location, we have to increment the current value of SI, source index register content, means which is the offset address of or effective address of source string. So if I increment it by 1, it will go to the memory location where we have value E. Okay. So I have written increment SI. So you go to the this memory location where we have value E. Now same way we have to increment the destination. At 21st memory location we have stored W, and this E has to be stored at 22nd memory location. So that for that purpose I have incremented the DI2. DI refers to the destination index register. Now I have moved one character from one source string to the destination string. So one character I have done already. So I have to decrease the count by 1. For that purpose, I have written instruction DEC CX. So currently in CX we have value of count. Count is 7. So whenever 7 is decremented by 1, it will be 6. So 6 characters are remaining to be moved from source string to the destination string. Now here I will check whether that number of characters I have finished or not. Still 6 are pending, means your answer will generated. 6 is nothing but non-zero value. It will reset the zero flag. It will reset the zero flag after execution of DEC CX. And if the zero flag is reset, it indicates that still some characters are to move from source string to the destination string. Now current value of CX is C after DEC CX instruction. So 6 will reset the zero flag. This resetting the zero flag indicate characters has to be moved from source string to the destination string. So I have written instruction jump if not 0 up. Means if the zero flag is not set, or we can say reset, it will move to the up and it will repeat the execution. It will take again content of offset address of SI. Content of offset address of SI is nothing but E. That E will be copied into the AL register. That AL register content will be copied at the destination index register content, and it will be stored at 22nd memory location. Again we have to go for next source characters, that is L. So I have to increase the value of SI. I have to increase the value of DI to store 23rd to store this L into 23rd memory location. So this is how we will repeat the process until we reach to the end, the E here. When after this the CX count becomes 0. Whenever after this CX will be reduced to 0. Whenever CX is 0, the 0 flag will be set, and as soon as the 0 flag is set, this JNZ up instruction is not going to execute. It will go for next memory location. So at next instruction, it will execute this instruction to terminate the program. Now here before instruction, it will add memory address to be 52B3 as to 000. We have welcome. So from these 7 characters, we have this W as first, 0001, 0002, 0003, 0004, 0005, 0006, and 0007. So E will be situated as 0007. And as I told that after first character 20 by difference we have made with the help of this move DI instruction. So at 20th memory location we have W, 21st memory location we have W. After that E, L, and WEL, COME respectively. So this is how we will move the string from source to the destination without using move USB instruction. Save this program. So whatever we have written after the end instruction will not be taken into the consideration by the compiler. So this will be treated as comments. Save it, exit. Tasm file name .asm. File name is axpt10b.asm. 10b.obj. We are linking the object file td expt 10b.exe. So we have come to the processor window. Now here, see carefully. Now here we will do the execution step by step again. Move AL comma content of SS. So W will be copied into the AL register. You observe here lower byte of AL register. Cursor. See, for W we have value 57. And here we will see the results. If you observe carefully, we are moving the characters one by one. In the REP move SP directly we came from 7 to the 0. But here we are going from 7, 6, 5, 4, 3, 2, 1 like this. As here we are moving characters one by one. If you observe carefully here, first string is loaded here, source string, that is welcome, and total 7 characters are there. Out of the 7 characters, we have moved 2 characters. So remaining 5 characters are remaining here, CRCX register. Now here we have moved 2 characters. If you observe here, see W and E is moved. This E and BYV, it is of previous string. So that are replaced with now new destination string. And if you observe carefully here, this welcome, the difference between this welcome and source strings starting address and destination starting address, the difference is 20 only. Now we will see how it will change, it will transfer character by character. Del of FA. Now see here, the instead of E, it is replaced with W, sorry, L. Now next character should be C. Now C has awkward here. next character will be O. O occurred, M occurred. So WELCO and next we will do again so that E will come. Now E has occurred. So we have transferred the source string from source string to the destination string. See here, this one at the center bottom, see in white color. Welcome string is there. Same is we have copied or moved character by character to the destination string here. Okay, so this is how we can move the string from one location to the another memory location with the without string instruction. Without string instruction means without use of MOVSB instructions. Wait. Now next our program is to reverse the string. Our next program is to reverse the string, that is the 11th experiment. So I have stored it with 11.asm. Sorry, edit expt 11.asm. Now here this is the program which to reverse the string, means we are having group of characters and we have to store that group of characters at the destination in reverse order. Okay, so same string I have taken here, dot model small dot data, same string I have taken welcome, and count is 7 only as usual. As usual I have done code segment initialization. Now here in of 20 I have taken 50. So destination string will start 50 location apart from the source string. It is loaded into the CX register as usual, and effective address of source string is loaded into the SI register. Now SI register will be available here, and we want the characters to be printed from the sequence OCLEW, like this in reverse order. Now if I am available at character W and I want to copy it from character E, so what I will do, if I add 7, my 7 to SI, that's index register content, which is nothing but effective address of the source string welcome. So if I add 7, the compiler or cursor will go here, one place next to the E. Okay, but I want the cursor to be at E. So what I have to do? I have to decrement SI by 1. So instead of decrementing SI by 1 at this position, what I will do? At first, I will go to the previous position of W. I will go to the previous position of W. So I have decremented the SI content by 1. So my compiler will come over here, the previous memory locations before W. Okay. Now I will add 7, that is total 7 characters are there. If I add 7 to the SI content, I will reach to the character E, and from that I will copy the one character by character, and that I have done with the help of instruction add SI comma CX. So SI content which is presently before W character W, and count of CX is nothing but 7. So 7 will be added to the current SI. So if my cursor is here, okay, and if I 7 here, it becomes come to the character E. It will come to the character E. Now from here, I have to copy one character by character, and I have to place it into the destination string in reverse order. To come to the reverse order, I have to decrement the SI content. I have to come to the reverse order to decrement the SI content. So SI content, if I decrement it by 1, the compiler will come over here for next character E. Sorry, E after E, it will be M. After M, it will be O, then C, then W, then E, and W. L, E, and then W. So this will be the sequence. To get that sequence, we will decrement the SI content. So now first what I will do, I will move the SI content, which is currently E, from that character I will place in AL register, lower byte of AX register, and that same content I will copy it into the destination, which is whose offset address available in DI register. So at the destination string, which is represented by offset address of DI register, we have character E and we have character E. Now I have copied character E from source to the destination. Now next I want to go here and I want to copy M. My source index register is indicating the figure here. So if I decrement it by 1, I will reach here to the character M. So that's why I have written DEC SI. So if I decrement SI, so I will reach to the character M. Okay, I will reach to the character M. Now I will reach to the character M. And this is about source string. About destination, at destination which is 50 memory locations apart from the source, it will be that destination should be go to the next memory location, as it will we are going sequentially for destination string, so it should be incremented by 1. So that's why I have written increment DI. So DI register content will be incremented by 1. So next memory location will be available for destination string. Now we have moved one character. We have to do likewise 7 character we have to move. So for that purpose, we have kept the counter in CL register. Now I have copied one character. So count should be decremented by 1, and I have to go and checking by this way. I have to check whether I have copied or moved all characters from source to the destination. If I reach to the 0, means CL contents become 0, I have to stop the operation. If not, I have to continue the operation. Whenever that CX becomes 0, 0 flag will be set. It indicates that we have reached up to the W. We have reached up to the W and we have to stop the operation. Now currently we are at M position and we want to continue the operation of moving the characters from source to the destination. So I have decremented the CX, then CX becomes 6. As it is not 0, 0 flag will be reset. Means this condition for this instruction JNZ up will be satisfied. Jump if not 0. Correct? Currently CX register content is not 0, so 0 flag will be reset, which is the true condition for this JNZ up instruction, and a compiler will come over here again. It will copy the next character, that is M, from string to the AL register. Now that M will be copied into the destination. Now we have done two characters copy. We have copied two characters from source to the destination. This is how the process is repeated until we reach W. Whenever W is copied at the destination, the reverse string copying the reverse string operation is completed and CX becomes 0. As soon as CX becomes 0, it will set the carry flag. As the carry flag is set, it will which is not correct satisfied condition for JNZ up instruction. So this instruction will not be executed. It will execute next 3 instruction to end the program. MOVH, 4CH, INT 21H. So this is how, if you observe carefully, the welcome string is like this, and so it is at say memory locations say 000. If you assume that it is started at memory location 004 times 0h, and the destination string will be 50 memory locations apart from the source memory locations in reverse order. So characters are copied in reverse order. This is how to reverse the string. Now we will see the execution. Save the program first. Go to File, Exit. Target file name is expt11.asm. T-link file name expt.obj. td file name is sorry, we have done mistake here. I have written only expt, actually expt11. So we'll link again files. See here, the error has occurred, unable to open the file because that file is not exist. Our file name is expt11 and I have typed expt. So t-link expt11.obj td expt11.exe. So we came to the command window and we will start the execution with the help of F8. See, in destination register we came to the memory location 50 and so our count becomes 7. Now we will see the see this is our string welcome and this has to be replaced at 50th memory location. If you observe here, at this memory location, the string is started to become in reverse order. If I type it, now C has occurred here. COME has done now. Goes on doing F8. L has occurred. And W has occurred. So if you observe carefully here, we have reached, we got the string EMO CLEW. So we got the reverse string like this. So we have reversed the string and our string is at our address this welcome string. This is source string and this is destination string in reverse order. So this is how we can reverse the string with the help of our 8086 instructions. Wait it. Now our next program is to actually compare the two strings. The comparison of strings is done with the help of two's complement method of subtraction. There subtraction is done and if the result generated is 0, it indicates that we have it indicates that strings are equal, then 0 flag is set. If strings are not equal, then 0 flag is reset. That we will see in next video.